Okay, chapter 2, data description. Types of data set. First section is the types of data set. We have two types of data set, univariate and multivariate. But univariate means only you have one variable that you want to make your study about it. Like what, for example, like price of oil. Okay, it's only one variable, or price of gold. It's only one variable, or maybe temperature, it's also one variable, and maybe import or export. Okay, if you have only one variable, that means you have a univariate data set. Multivariate, it's more than two variables. For example, I want to study the oil price. Okay, that oil price depending on what, depending on oil gold price and also currency, for example. Okay, or maybe dollar, let us say. So we have three variables, one of them depending on the other variables. So it calls a multivariate data set. And also you have bivariate. Bivariate is a special case of multivariate when we have only two variables. Okay, only two variables. Okay, we explain it. But now, just like a review for you, we have quantitative data set and we have qualitative data set. So that means quantity and quality. Okay, and we talked about that quality is categorical type of data, which is describing something, describing a variable or describing a situation, and so on. Quantitative, we said that it's numerical data. Okay, that's the explanation of multivariate. We explained it in the previous slide. So multivariate must be more than two variables, and bivariate is only two variables. Okay, as it's shown here, only two variables. Okay, displaying categorical data. How we can display the categorical data? We can display it through the frequency distribution or frequency table, bar chart, pie chart, and dot plot. Okay. Also, we have relative frequency, which is frequency divided by total of the cases or total of the data set that we have. In an example, we will explain all of them. For example, let us say of this raw data that you have. This raw data, we collected data from the staff, it's staff information at the School of Computing, for example. How many persons we have in the school? Look at the staff column starting from 1 to 140. So we have 140 persons in the School of Computing. Okay, we took some information from them. The first information is position, blood type, weight, height, qualification. So how many variables we have here? 1, 2, 3, 4, 5. So we have 5 variables. So this table is multivariate. Why? Because we have more than one variable. Okay, the first variable is position, the second is blood type, the third is weight and height and qualification. So for each person we have 5 informations. Okay, for person 1 we have 5 information, which is position, blood type, weight, height, qualification. Okay, now if you are looking at this table and it contains 140, you cannot understand anything. Okay, you cannot understand a table contains 140 informations. Okay, and for each person you have 5 information, so you cannot, it's not easy to understand it. So what we should do, we should use table frequency to convert this 140, okay, to a table contains 10 on 15 or 20 information. Okay, how we can do that? For each variable we have to do, for example, for position it needs a table frequency, for blood type another table frequency, and for each variable is the same. Okay, let us start here. So for position, how many positions we have in the main table? We have lecturer, we have professor, we have senior lecturer, and we have associated professor. Okay, and we have tutor. So these categories that we have in the table, these types we have. Okay, so you are putting all of them. How many professors we have in the main table? Okay, you have to come and count it by yourself. For example, 1, 2, and we know it's an incomplete table. So if you have the whole table, so you are counting it till you get the last professor. So in 140 persons in the school, we have 12 professors. Okay, and we have 20 associated professor. We have 59 senior lecturer. Okay, and we have 40 lecturer, and we have 9 tutor. So summing of these numbers from 12 to 9, 12 plus 20 plus 59 plus 40 plus 9 must be equal to the whole number that we have, which is 140. Okay, if it doesn't, that means you make a mistake. Okay, you have to fix it. This is stable frequency. So what's relative frequency? When we mentioned its rule, it's easy actually. The frequency of professor, for example, it's 12. Its relative frequency will be 12 divided by 140. Okay, divided by 140. For associate professor, 20 divided by 140. For senior lecturer, 59 divided by 40. Also for lecture, also for tutor. So this is the relative frequency as it's shown here. So summing of relative frequency 0.09 plus 0.14, 0.42, 0.29, 0.06 must be equal to 1 always. Okay, for your double check, after you are finding the relative frequency, it must be equal to 1 when you are summing all of them. So because we cannot and easy understanding the raw data set that we have, which was information of 140 persons, for understanding it we make the table frequency. Okay, table frequency and relative frequency also, it's another way to present your data, but in probability. Okay, in probability term. This is numerical term. Okay, mathematical term. This is probability term. We know that probability is always fall between 0 and 1. Okay, we have another data set here. It's bivariate. Why it's bivariate? Because we have only two variables. The first variable is age, the second is net use. Okay, age and net use. So it's the same, but to present the whole data, that's why we split them in 6 columns. Okay, actually it's only 2 columns, age and net use. Okay, how many data set do you have? Let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10. How many columns you have? 1, 2, 3. So we have 30 observations. 30 observations for each variable, and it's two variables, so it's bivariate. Okay, now if we use the response of the persons when we are asking them how old are you and net use. Okay, are you using net or not, yes or no. Okay, so if we take the response variable yes or no, in the 30 persons that we have, 17 of them not use net, 13 of them use net. Okay, how you can find it? You can compute it. How many yes we have? 1 2 3 4 5 here. Okay, 5 6 7 8, last column 9 10. Okay, 9 10 11 12 13. So we have 13. So the other number that remaining, it's no, which is 17. Okay, also you have another answers for this question, are you using net or not. It's not only yes or no, maybe sometimes don't know, maybe sometimes not applicable, maybe sometimes no answer. Okay, or no response. Okay, but we only take here the yes or no. Okay, for this example, yes or no, how you can find percent, how you can find, for example, relative frequency, how we can find it. It's easy actually. 17 divided by 30, 13 divided by 30. This will be the relative frequency. Okay, and also for percent or percentage value, 17 divided by 30 times 100, it will be 56.7. And also for this, it will be 43.3. Valid percentage is the same of percent. No need, actually, no need here. Okay. Cumulative percent. How we can find cumulative percent? Always. The first cumulative percent will be the first value of percent, which is 56.7. So you are putting the same number here in the first place. After that, this number, which is 56.7, plus the next percent, which is 43.3. Okay, it's equal to 1. Always cumulative frequency, last number of it will be equal to 100. Always, for your double check. Okay, another example about NMM's chocolate. We're talking about colors here, so we have only one variable, which is univariate here. Why? Because we have only focused on the color, okay, of N and M's. So this is the colors that we have: yellow, blue, orange, green, and so on. Okay, if you take the frequency, we are putting types of color that you have, how many colors we have in the N and M bag. For example, you have a bag of N and M's. When you open it, there is a varied color of the seeds inside it, which are the colors are yellow, blue, orange, green, brown, and red. Okay, so how many yellow seeds we have in the bag of N and M's? It's 10. How many blues we have? 3. For example, let's count the blue in the raw data. So this one, okay, this is one, and in this column we don't have it, in this column we don't have it, here we don't, also here, yes, this is 2. Okay, and this is 3. So that's why we, okay, that's why blue is equal to 3. Okay, and also for the other colors, so the total number of frequency must be equal to 45. Why? Because we have 45 seeds. If you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many columns we have? 1, 2, 3, 4, 5. So 5 times 9 equal to 45. Okay, relative frequency, how you can find it? 10 divided by 45. 3 divided by 45. 6 divided by 45. And also for the other colors. So this is the relative frequency. Summing of them equal to 1. It must be equal to 1 because it's probability. Okay. Bar chart. How we can use bar chart? For example, in this example, if you are looking at the bar chart that we have, how many variables we have? We have 1, 2, 3, 4 variables. Which are the countries? England, Scotland, Wales, and Ireland. Okay. How many categories we have in each country that we want to study? We have self-catering, caravan, camping, and hotel. Okay, so it can be presented like this. When you have the data set in Excel sheet or in R language software or maybe SPSS, so you can make the plot like this. Okay, the bar chart like this. And also it shows the frequency of each category. For example, of the blue color is self-catering. So this is the blue color, self-catering. It's approximately 28. Approximately, okay? Approximately 28. For caravan, this color is caravan. So it's approximately 7. 7, 6, 7 maybe. Okay, approximately it's equal to 7. Camping, it's approximately 12. Okay, it's above 10, so maybe it's 12. The last one, hotel, here is the greatest frequency we have. Maybe it is 50, 55. Okay, it's between 50 and 60, and so on. For the other country, you can use the same interpretation. Here we have, if we take the previous example that we talked about the position, how many professors we have among 140 in the School of Computing, we had 10. When we solve it, we had 10. So if we make a show the table in bar chart, it will be like this. So this bar chart is related to this frequency table that we made, this one. Okay, professor, we have 12, associated, 20, and so on. Okay, if you want to show it like a bar chart, it will be like this. So if you are looking at the professor, it's above 10, it's 12. Okay, above 10, value is 12. And for associated, when you are moving the pointer on it, it gives you that the value is 20. Okay, here it must be 59, so it's writing value 59. Okay, and so on for the others. And if we want to show the bar chart of the position by using relative frequency, let us go back to the table. Okay, first relative frequency is 0.09, second is 0.14, third is 0.42. Okay, if you want to make the bar chart for the positions with using relative frequency, it will be like this. So from 0 to maybe 1, maybe 0.5, it's up to you. The largest number that you have in the relative frequency is 0.42, so you can use 0.5, you can use 0.45, 0.42, maybe 0.43, it's up to you. So here it uses 0.45. So this is the first one, which is 0.09, the second one 0.14, this one 0.42, and so on for the other category that we have. Here you can put the bars horizontally or maybe vertical, it's up to you. Okay, here we have horizontally, it's the same. Okay, the same, but this one is for frequency. Okay, we have here the value, and also here, and so on. How we can make it, we will make a video about how we can converting data set to bar chart or to pie chart or to any plot that we want. Okay, we'll make another video about these stuffs. No need here to explain it. And if you want, maybe you have a data set in the columns, column A, for example, and column B, how you can make the bar chart. You are going to insert. After that, you are choosing the bar chart or maybe the line chart or bar chart, and also horizontal bar chart, area, and scatter plot. We have a lot of types of plots that you can present the data set. Okay. And here in SPSS, actually we don't study SPSS here because we have to focus on R language. As it's mentioned in the course of information, we will use R language. Also, you'll make a video about how you can install R language and how you can use it and how you can insert data in it, data you making data entry, and how you can uh, make the plots or table frequency or these stuffs that we talked about. This is our language. Okay. Okay, let us talk about this example here. Uh, Source of funding. We have student loans and parents or family scholarship. Okay. Have female and male. So how many females we have? We have 100 students. How many males we have? We have 60. So the total number is 160. The total number 160 overall if we talk about. But when we are studying the gender, so it will be 100 for female and 60 for male. Okay. How many categories we have? We have three categories. Okay. Maybe the student has a scholarship, maybe her or his family pay for him, or maybe student loans, and it's up to the data set that we have. So here we have of this form. Okay, now if you want to find the relative frequency for each of female and male. Okay, for female we have 50, okay, divided by 100, it's equal to 0.5. 30 divided by 100, it's equal to 0.3. So 20 divided by 100 is equal to 0.2. Now for male, 30 divided by 60 equal to 0.5. 20 divided by 60 equal to 0.33, and 10 divided by 60 equal to 0.70. Okay, so summing of each of them must be equal to 1. Okay, and you can show a comparative. For example, here you have frequency, this is for frequency, and this for relative frequency. Okay, this for relative frequency. Pie chart. Also, you can present data set. It's easy, that's why I don't want to explain it here, but in the video of R language or Excel, I'll explain all of them, how you can do that, how you can split them, how you can link them, how you can show two-dimensional pie chart or three-dimensional pie chart, and also you'll solve this exercise there. Okay, you have 92 people were asked how to how they go to work 35 of them using car, for 42 public transport, and 8 bicycle, 7 walk. Okay, so you can make a relative frequency. If you want to make the relative frequency, you have to put the table like this: car, transport, bicycle, walk. Frequency will be for first one 35, for second one 42, for third 8, and last one 7. So summing of them must be equal to 0. Must be equal to 92. So if you want to make the relative frequency, it will be for first one 35 divided by 92, second one 42 divided by 92, 8 divided by 92, 7 divided by 92. So this will be the relative frequency for this example. And you can make bar chart or pie chart or horizontal bar chart. It's up to you. Okay, we finished the categorical data set or quality data set. Now, what if we have the quantitative data set? For quantitative data set, how we can use it? So when you're talking about quantitative data set, there's only two types: ungrouped data set and grouped data set. Okay, ungrouped and grouped. Okay, and we have two types of them. For grouped and ungrouped, we have discrete and continuous. Discrete and continuous. So what is discrete and what's continuous here? Continuous and discrete: any numbers or any variables that take integer numbers, it will be discrete. Like what? Like I'm asking you how many brothers you have. So maybe you say no brothers, or maybe you say one or two or three. So you're talking in integer numbers: 1, 2, 3, 4, 5, and so on. Okay, there's no decimals. You are not saying I have 1.5 brothers. It's impossible. Okay, you are counting cars on the street. How many cars you count in 30 minutes, for example? Maybe you say 100 cars. You are not saying 100.5 or 100.1 cars I counted, because each vehicle is a number. Okay, each vehicle is a number. Okay, how many students we have in the class? 50, for example. So we have 50. It's not allowed to say we have 50.8 students, because each person take an integer number, so there is no decimals in the data set. Okay, we are talking about continuous. Continuous, like what? Like time. Like time. So I am waiting you half hour, for example. So it's 0.5 hours. Okay, maybe wait. Okay, wait. I am 70.4 kilogram, for example. Height, I am 160. That means 1.6 meters, for example. Temperature is also continuous. So this is the continuous and this is the discrete. Continuous in general or discrete in general, there's no point in the data set. But continuous, there's point in the data set. This is if you have a data set without mentioning its variable. Only if I given you two set of data and I do not describe the data is related for what. Only you have a data set. If there's points in the data set, it will be, you can say it's continuous. If there's no point, you can say it's discrete. But maybe I'm giving you a data set and there's no point in the data set. All of the data set is integer numbers. Okay, but I told you that this data set is related to temperature, for example. It's true there's no points in the data set, but because it's temperature in its nature can take points. Okay, so you have to say it is continuous. Okay, and you have some examples here. For example, for ungrouped data, this ungrouped data, you have numbers 0, 1, 3, 4, 5, and so on. Okay, so it is discrete. Why? Because there's no description of this data set. We don't know of which variable is it. Only we know that there's a large number of data set here, but they are integer numbers. There's no point in the data set, so it is discrete. This data set also, there's points in the data set, so it is continuous. Okay, grouped data. This was ungrouped data. If you want to make it to convert this ungrouped data to grouped data, we have to find table frequency. So table frequency is grouped data. Okay, the raw data that we have is ungrouped data. Okay, if you convert this one to grouped data, this is the frequency. Okay, okay, and so on. Continue. For example, in the huge data set, we have 15 zeros, and we have 28, 21, sorry, and we have 82, and we have 53, and so on for the other numbers. Okay, for the other one, which was continuous, also you can make the table frequency here. Frequency distribution, in the example we can, let us solve this example here. We have a data set without description. Okay, it's true that it says it's discrete data. Even if do not mention this, you have to know that is discrete. Why? Because there's no point and there's no description, so it's discrete. Okay, how many numbers we have? We have number from 1 to 10. Okay, 1 to 10. So marks you are putting from 1 to 10. We are using tally method. How many ones we have? This 1, 2, this is 3. So you have drawn 3 lines. So it's equal to 3. How many 2 we have? We have 3 2. 1, 2, 3. So 1, 2, 3. Also 3. And so on for the other numbers. The total number of frequency, we have 30. So if you count them, it will be equal to 30. So we have 30 here. This is ungrouped data. We convert ungrouped to grouped data. This is grouped data and it is discrete. So now you can find relative frequency. You can make a bar chart and any type of charts that you want that deals with the quantity data set. You can use it. Okay, this is the frequency. This is relative frequency. We know how to find the relative frequency. 3 divided by 30, 3 divided by 30, 2 divided by 30, 2 divided by 30, and so on for the other numbers. And the total of relative frequency must be equal to 1, and also it's equal to 1. Cumulative. How we can find the cumulative frequency? We said that the first cumulative will be the first relative frequency. Okay? This is cumulative frequency for what? For relative. Also we have cumulative frequency for frequency. Okay, now the first one is 0.1, so you are putting 0.1 here. 0.1 plus the next one plus 0.1, 0.2 plus 0.067 equal to 0.267 plus 0.067 equal to 0.334, and so on. The last one must be equal to 1 for your double check. Okay, and how we find the percent? The percent is 0.1 times 100, and so on for the other ones. Okay, you can find the percent of frequency. And here 0.2 times 100, and all of them times 100, it will be these numbers. Okay, another example here we have. This is ungrouped data also. We have this the data set that we have. Okay, also it's discrete. So we are putting classes here based on what we are putting these classes here. Look at the data set that you have. The smallest value is 58. This 58 is the smallest value. Okay, so you can put this small value here, or maybe you can put a value smaller than it. For example, it's up to you how you are making it. Okay, in this example, he put is 50 to 59. Then after that, adding 10 for each class. So the class you have lower limit, and this is upper limit. Lower limit is 50 and upper limit is 59. For the next class, adding 10, 50 plus 10, 60 plus 10, 70 plus 10, 80 plus 10, 90. And here 59 plus 10, 69 plus 10, 79 plus 10, 89 plus 10, 99. So the largest number that you have in the data set is 96. So you are continue of making new classes till your largest number will fall in the class that you have. So we don't go to 100, 109. Why? Because our largest number is 93, and 93 is fall in this between these numbers that we have 90, 99. So we have to stop. Okay, we have to stop here. Central class that you have to calculate it. Central class or midpoint, sometimes we are calling it midpoint, and sometimes center, class center. How we can find these numbers? You have the class 50 to 59. So 50 plus 59 divided by 2, it's equal to 54.5. Okay, this is the midpoint between the lower and the upper limit of the class. Okay, for the second and to the last, you don't need to take in the average of these two numbers. We have the difference between two classes, it's 10, right? 50 and 60, the difference between them is 10. Or maybe you can use the upper limit, 59 and 69, also 10. So we have the first midpoint, add 10 or plus 10 equal to 64.5, plus 10 plus 10 plus 10. That means if you have the first value and if you know the difference between two classes, so you can add the number that you have to the difference of the classes, so you can get the midpoint for whole classes that you have. Okay, so you can count like this, compute them like this, 60 plus 69, 70 plus 79, and so on. Or maybe you have the first one and you know that the difference between two classes is 10, so adding 10 in each step, so you can get the whole center, class center. Okay, and for frequency, how many numbers in the raw data, in the ungrouped data we have that fall between 50 and 59? We have only 58, so that's why we put 1. Okay, we put 1. How many numbers we have between 60 and 69? We have 7 numbers. Okay, if you count from 60 to 69, 67, sorry, 65, this is the first number. 64, this is the second. 66, 3. 63, 4. Okay, 63 again, 62, 61. Okay, so it will be 7 numbers, and so on for the other numbers, for the other class. So we have frequency, and summing of frequency equal to 60. Also we have 60 numbers in ungrouped data. Okay, if you have a continuous data set, how you can make it? The smallest value that you have is 5.1. So you can put 3, you can put 2, you can put 5. Okay, it's up to you. You can put 4. So we put it here 5 to less than 10. That means 10 does not include in this class. Okay, it's starting from 5 to 9.99999. Okay, here second one start from 10 to 14.999. 50 does not include, and so on. Okay, so we put 5 to less than 10. Okay, 5 to less than 10 plus 5. Why we adding 5 to each class here, but in the other we put 10? Because the numbers is small here. Okay, it's up to you. It's not wrong if you are putting 5, if you are putting 10, if you are putting 3, for example. So if you are putting 3, 5 plus 3, 8. Okay, and here 10 plus 3, 30. Okay, 30. So and so on, 3, 3. You are adding 3 to here, adding 3 to here. Okay, but here we have 5. 5 plus 5, 10. 10 plus 5, 15, and so on to the last one. Why we stop it here? Because the largest number that we have is 28.1. So we have here 30. So we have to stop. Why? Because our large number, which is 29.7, sorry, fall in this class. So no need to continue making classes. Okay, how many numbers we have starting or falling from falling between 5 to less than 10? We have only one number, which is 5.1. How many numbers we have falls between 10 to less than 50? Less than 15. We have three numbers, which is 14.6, 10.3, and 12.1. So this is 3, and so on for the other categories. Okay, there's another way you can show the tables. For example, here we have 150. That means x, which is the variable. X is a variable. Okay, also here we can put x less than, for example, we are putting x between them, and the sign will be here x greater than or equal to 5 and x less than 10. Also you can present it like this table. Okay, here we have 150. Okay, one is missing here. Okay, it's missed here, so it's 115 and less than 155. So 155 to less than 160, and so on. So the difference between classes is 5. Okay, is 5. Okay, dot plot also. We have another plot. Actually, you are explain them in the R language, but only for information. You have minutes here 0 to 12, and we have people here. Okay, so for dot plot, the minutes you have 0 minute to 12 minute. Okay, in 0 minute, how many people we have? We have 6 peoples. 0, 6. So you are putting 6 pointers here. This data set is a mixture data. How? The people, number of people is discrete. We know it's integer number, but the minutes that you have, it's continuous. It's time is continuous. So you have two type of data set. Okay, it's mixture data set. So 1 minute you have 2 persons. This one you have 2 persons, so you are putting 2 dots here, and so on for the other one. Okay, histogram central value. We'll take an example here for making histogram. How you can make a histogram manually. If you are using software, it will doing it for you. But if you are doing it by yourself manually, you have to use these rules. Okay. The first rule that we have, you have to find the range of the data set that you have. The range, this is the rule of range, which is equal to largest number, highest number minus lowest number. Okay. R equal to highest number. Here R is range, XH is highest number, XL is lowest number. Also, we have the another rule. I, you have to find the initial. I is equal to the range that you found by using the previous rule, which is equal to highest minus lowest, divided by 1 plus 322 log of n. So n is the number of observations, the whole numbers that we have. Okay, the whole numbers that we have. Okay, and also we are finding the error, which is equal to r divided by I. Okay, and midpoint, how we can compute midpoint. This is another way to compute in the midpoint. It's equal to xl plus I divided by 2. The lowest x plus I divided by 2. In the example, we are explain all of it. This is the example that you have. Okay, you have a set of data. The highest number is 2.575 and the lowest number is 2.531. Okay, so we can find the range if you are taking subtracting the highest number and the lowest number. Okay, before that, this table frequency you can make that was ungrouped data, you can convert it to grouped data. This is the grouped data according to the numbers without using classes here. Okay, without using class here. This is the frequency of the whole data set that we have. Now, using the rules to find the histogram, R equal to highest number minus lowest number. So R equal to 0.044. Okay. Cell intervals. How we can find the cell interval, the initial value? It's equal to R 1 plus 3.322 log of n. So how many numbers we have? 110 numbers we have. So if you are counting these numbers, these columns, how many numbers each column contain, and then summing all of them, it's 110. So n is 110. Here you have the r 0.044, 1 plus 3.322 log of n. N is 110. So the final number is equal to 0.055. 0.055. So we are using here 0.05. 0.005. Okay. No need to make round. No need to make round. Okay. 0.005. Okay. Now you have to use to find this the initial in the middle. That's in the red rectangular. So you have to compute a number above it and a number below it. Okay, so we use 0.003 below and 0.007 above. Okay, they must be of the same distance. Okay, we used 0.002. Okay, now you have to find h, which is the error. It's equal to r divided by I. So r is equal to 0.044 and I is equal to 0.003 that we put it by ourselves. Okay, we put it. Maybe you can put 0.004 for the lower and for the upper 0.006. It's up to you. Okay, in this example we put 2 points above, 2 points below, so you can put 1 point, you can put 3 points, you can put 5 points. It's up to you. So here it will be 15. Okay, 15, and our original, or in the middle, is equal to 9, and the other one equal to 6. So we have 6, 9, 15. Okay, how we can find the midpoint? The midpoint. If you don't have class, how you can find the midpoint? The midpoint will be the lowest number, which was 2.531, plus the the original I that we have, 0.005. Okay, not the I that we put it by ourselves, lower and upper, the middle one that we found it by using the rule. Okay, so this is the I divided by 2. It's equal to 2.533. Okay, 2.533. So this is the first midpoint. So we are putting the first midpoint here. Okay, now for the second, no need to use this rule. Actually, no need. Okay, no need. I is equal to 0.005, right? The I that we found, 0.005. So the first one plus 0.005 will be the second midpoint. The second one plus 0.005 will be the third one. The third one plus 0.005 will be the second one, and so on. Okay? So, do you want to take a rest? So let us take a rest. We will start again after 15 minutes. Okay, after 15 minutes we will start again. I'll send you the or let us keep this meeting. Okay, on the same link. We will start after 15 minutes.